Yeah, let me check the stream. Okay. Hello, hello. Mic check, mic check. Yeah, let me check the stream. Okay. Hello, hello. Mic check, mic check. Okay. Uh, so we are back again. Leetcode questions. Okay. Let me bring the timer clock. Is it timer alarm? I think timer. Yes. Okay, let's reset the timers. Okay. Okay. Here is the question. Okay. So the first question is this of today. Hmm. Uh, okay, let's start. You are given an M cross N matrix of character box, okay, representing a side view of a box. Each cell of a box is one of the following. A stone, okay, stone is represented by hash, a stationary obstacle is denoted by star, and empty is denoted by dot. Okay. The box is rotated 90-degree clockwise, causing some of the stones fall due to gravity. Each stone falls down until it lands on an obstacle or another stone or the bottom of the box. Okay. Gravity does not affect the obstacle position. Okay. And the inertia of the box position does not affect the stone horizontal position. Okay. Okay. It is guaranteed that each stone in box will rest on an obstacle, another stone or the bottom of the box. Okay. Written in N cross M matrix representing the box after rotation described above. Okay. So let's say this is the box, right? So after rotation, what will happen? It will become like this. This is in the bottom. This will go till here. Okay. Let's say, what is this? This is star. Okay. After rotation, it will become like this. It will still here. It will become here. Okay. 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 Hmm. Mm, okay. Fine. So if it is of M cross M, then after rotation, it will be what? N cross M. Am I right? So currently it has two rows and one, two, three, four. So it is 2 cross 4, right? After rotation, it becomes 4 cross 2, 90 degree. Okay, yes. Similarly, here it is, there are 3 rows and one, 2, 3, 4, 5, 6. So it is 3 cross 6, and after 90-degree rotation, it will be 6, comma 3, right? 1, 2, 3, 4, 5, 6, yes, and 3, comma 3. Okay, so now I know the final structure of the array, oh sorry, matrix. What I need to do is, after rotation, what will be the value of the current element? Okay, if an obstacle is there, then what will be the position? And if an obstacle is not there, then what will be the position? Hmm. In my opinion, I can do this. What I need to do is, I just need to rotate it, right? How can I rotate it? Let's say, suppose this is this, okay? I can simulate it like, let's say it is gets rotated. Then I know this will come here, this will come here, this will come here, right? Hmm. What is the time complexity? Okay, M. N is 500. That is fine. Okay. And we have to return it, but like this. Yeah. Hmm. Let's say iterate on this, iterate on this. This will go here. Okay. Fine. And I iterate on this. There is nothing here. Iterate on this. This will go until here. This will stop. Okay. Okay. Then let's say I didn't rotate first. Then what will be the configuration? 1, 2, 3, 4, 5, right? And there are three rows. Third one is block, the fourth one, and this one. And there are element inside here, right? 2, 3, and 4. So I know after when I rotate, it will come here. Okay. This will come here, this will come here, and this will come here, and this will be stopped. So it will be like this, right? Yes. Okay, I can do this, but now I want to rotate it, right? So what I will do, I will create a this matrix. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Okay. So this will come here. This will come here. Okay. This will come here. This will come here. This will come here. This will come here. And this will come here. Okay. Okay. So I understood the problem. So what I will do is I will not rotate it first. I will just, let's say gravity is this side. So what I will do is I will start from this column and I will say, is there any stone that can be shifted to the next column or not? Okay. Then I will start from there. Here you can see this column gets shifted to this. So I will push this here. Then from this, there is no column. Then from this, it will go until, but here is block. This will go until here because this gets shifted to here. So what I will do is, first of all, I need the dimensions. Dimensions will be box dot, sorry, size. Okay, and will be box dot, what, box of 0, sorry, box of 0 dot size. Okay, now I have the dimensions. So now what I will do is I will iterate on every column, right? So what I will do is for tj j equals to, and from last column. So last column is n minus 1 until on greater than 0 I j minus 1. Okay. What I will do is on jth column, what I will do is I will iterate on every row. Okay. So for integer I equals to 0, I less than n, I plus plus. Okay. So suppose I am in this j and this I. So what I will do is while there is a possibility then this that this can be shifted, I will shift. So what I will do is uh, let's say let's create a temporary variable temp equals to the j. What I will do is while this j is less than m, okay, while j is less than m, and then uh, while j plus 1 is less than m, and then the value of this, the value of box I and this temp, okay, it should be temp, while the value of this temp plus 1 is either what is empty, right? Because if it is a stationary obstacle, then I will stop. If it is an empty, okay. So while it is empty, what I will do is I will increment the temp. Okay. Now I know that this stone will be in the position temp. So what I will do is firstly I will remove the stone from the current j and I, current j and I. So what I will do is box of this I and this j. I will firstly empty it out, then box of this I and this temp will be now the store hashtag. Okay, one thing also, if box of I and j is not equals to hash, it means if it is not a stone, then I don't need to do this, right? Suppose it is this empty cell, then I don't need to do this. If it is an obstacle, then I don't need to do this. Okay, so what I will do this. Okay, so what this will do, j is here, they are not equal to, j is here. Okay, this is hash, right? So temp will be this, temp will be this. While temp plus one is less than n, temp plus one is less than n. Box of it should be temp plus one, right? Box of temp, it is empty, so temp will be here now. Okay, temp plus one is not less than n, so it will break out. So here it will become empty, and now this will become hash. Okay, so for this j is done, then for this j, then for this j. Okay, now I need to create my resultant vector integer resultant. It will be of different dimension, right? It will be of m comma vector of integer, and it will have n column. Okay, because this is was n cross n, and the resultant matrix will be m cross n. Now I need to fill this. So how can I fill this? Uh, let's say this is I, this is j. 2 0 1 2 3 4 5 0 1 2 3 4 5. Sorry. So this is 0 comma 2. So here it will be 2 comma 2. Okay. So this will become 0. This will become 2. This will become 2. Okay. This will become I. Okay. So what I will do is now I will iterate on for integer I equals to 0 less than n I plus plus, for integer j equals to 0 j less than n j plus plus. Now what I need to do is I need to fill this, right? So if it is I comma j, then in rotation it will be j comma uh what j comma 0 into 3. So if it is 2, then it becomes 0, right? So n minus 1 minus I, n minus 1 minus I. Am I correct? Let's say it is 0 comma 2. So it will be 2 comma n minus 1 is 3 minus 1 is 2, 2 comma 2. Okay. So what I will do is this resultant of j comma n minus 1 minus I will be box of I j. And then what I will do is I will simply return the resultant. Let's see. What happened? Oh, sorry, it is a character. Okay, sorry. Character, character. Okay. Mm, it's now fine, I think. Let's run. Okay, now it is getting accepted. Uh, will there be an issue? Let's see the dimension. One. Let's say if there is only one element, right? Then what happen in that case? Hashtag is not a valid type of character. Why? What happened? What happened? What happened? Okay, let's submit it. I think so. It should work. Okay, yeah, it get accepted. The time complexity of this question will be this will be n square, and I'm again iterating on the whole array, right? So it will be n cube for this loop, and it will be n square for this, right? I can make it n square. Hmm. Can I make it n square? I think I can make it n square. I can reduce this loop. How? Let's say I will take a temporary variable which will store which sorry, for the ith column, which position is available first, right? Let's say for this is the first position available. For this will be the first position available after it gets removed, right? Hmm. I know this, but I don't think so. Now is the time. Okay, let's move to the next question. Okay, let me drink water. Okay, let's start the timer. Minimum adjacent swap to reach the kth smallest number. Okay. You are given a string num representing a large integer. Okay. An integer k. Okay. We call some integer wonderful if it is a permutation of the digit in num. We call some integer wonderful if it is a permutation of digit in num and is greater than the value num. There can be many wonderful integers, however, we only care about the smallest valued ones. For example, when num is this much, the first smallest wonderful integer is this 548355214, right? 142, then 214. Okay. Second is 241, third is 412. Okay, okay. So we only care about the smallest value. Return the minimum number of adjacent digits that need to be applied to now to reach the kth smallest wonderful integer. Okay, the tests are generated such that the kth one exists. Okay, so it should be greater than it. Am I looking for the next permutation? Yes, I think so. Let's take the example. Example is 54893555142, right? So the sorry, next will be 142, then it will be 214, then it will be 241, then it will be 412, then it will be 421, Okay. So this is first, this is second, this is third, this is so fourth is 412. Fourth is 412. 4 to 1. Okay, sorry. This is 1, 2, 3, 4. Yes. So fourth is 4 to 1 in the last. So from 1 4 to I need to do it 4 to 1. So what is the minimum number of swaps? Hmm. So what I will do is I need two swaps. Uh, uh, say 1 1 1 1 2. Okay, so next will be 2 1, right? Okay, then it will be 1 1 2 1 1 2 1 1, not 2 1 1 2 1. Yes, so we are looking for the next permutation. So what can I do? What should I do? What can I do? Let's see. Nums length is 1000, k is also 1000. Nums only consist of digits. Okay. They are saying return the minimum number of adjacent digits swap. Adjacent digits swap, right? Adjacent. I can only swap adjacent. So firstly, what I think I need to do is, firstly I need to check, sorry, firstly I need to know which digits are getting swapped. Hmm. Like for this example, this is 142. And I'm looking k equals to 4. K equals to 4. 4 2 1 2 1 4 2 4 1 4 1 2 4 2 1. Okay, okay, okay. Can I generate next permutation in O of n? Uh, yes, I think so. I can generate next permutation, right? Yes. So next permutation is this. Let's say it is 5, it is 142, right? So I know, okay, first what I would do is, hmm, what should I do? So first I would do is, uh, should I do 142? Can I do, what can I do? 142. So it will be like this, increasing and then decreasing. So 142. So now 142 is done, right? So from 1, you can see that it is getting decrement. From 1, it is getting decrement. So now it will reset. Now instead of 1, whatever is the minimum value on right hand side will be the x. So it will be 2 and this will be sorted 1, 2, 1, 4. Okay, I'm not thinking clearly. The tests are generated in such a way that the create smallest wonderful integer always exists. Hmm. They are not saying to generate this number, right? They are just saying return the minimum number of adjacent digit swaps that needs to be applied to them to reach the kth smallest wonderful integer. Okay, adjacent digit swaps. Hmm. Okay, so let me check one thing. Next permutation series. Okay. Uh, what is the time complexity? Time complexity is, oh my god. Okay, O of n time, right? Okay. So what I can do is, I can generate the next permutation till this. So it will be of time complexity this into this, right? And after that, then I will have the original array. Then I can calculate the minimum adjacent swap, right? Is it good? Okay, so 5489355.42. But then how will I calculate the number of adjacent digit swaps? Let's say it becomes what 142. This becomes 241. No, 421, right? Okay. How do you calculate minimum adjacent swaps? What is the maximum can be employed. Minimum. If I want 4 in this place, then I need to shift this. Hmm. Okay. Okay. This is 1 1 1 1, right? Okay. So after it will be become 2 1 1 1. Okay. Yes. Okay. So this is fine. This is fine. This is fine. This and this is not fine, right? So what I'll do is this want to go to this position. Hmm. Shading. Let's say adjacent digit swaps. Let's say I calculated the addition. So they are saying what is the minimum value. Okay, so first of all, what I need to do is I will remove the prefix which is equal, and I can start from here. Then from here, what I need to do is I need to calculate minimum adjacent swap. How do you calculate minimum adjacent swaps? Hmm. 1 1 1 2 2 1 1 1 1 1 2 2 2. Yeah. 2 1 1. Okay. So what do I need to do? 0 0 1 3 2. Oh, okay. Let me think clearly something different. Maybe there can be duplicates, right? Okay. So let's say this is one, right? Okay. What I'll do is I'll add it on the array. I got it. I swap it, swap it, swap it, swap it, swap it, swap it. Like this. What is it? One time. Okay. One is good. One is good. One is good. Okay. So I think now I've got the intuition. So what I will do is I will call the next permutation. Okay, this is an array. Here are here plus 3. While k, let's string temperature num. While k minus minus, let's call this function next permutation. Does it work on string? temp begin, temp dot end. Let's see. Return 0. See out. Let's see whether this works on Q4 to. Okay, it works. So now what I will do is this will be of the time complexity k into n. Now what I will do is I have a temp, I have a number. Okay. So 54893555142. So what I will do is I will create a I variable, and what I will do is while I is less than num dot length. Okay. Okay. So if and the operation, let's say it is operation 0. Let's say if I sorry temp of I is equals to num of I, then I should do what? I should increment I and just continue, right? If it is not equal, then I will iterate, right? So integer j will be equals to I plus 1. Okay. So let's say they are not equal, right? So like this, but 1 1 1 2 and 2 1 1 1. Okay, let's see. So the value I need to find is teacher value I need to find is this temp of I on the right hand side of nums of I. So what I will do is while j is less than uh let's say a variable integer n equals to num len gth. Okay. Okay, while j is less than and uh num of I, num of j is not equals to n, then I will increment jj. Okay, now I got the j. Now I got the j. Right? J is here. I is here. So what I will do? I will do a swap. So while j is not equals to I will swap j, sorry, num of j, comma num of j minus 1. Okay, and I will decrement j, and I will increase the operation. Okay, while j is not equals to I. So this will 2 1 and j will be here. J is not equals to I. This will be 2 1. J is not equals to I. This is 2 1. J is not equals to j is here. Now it will get stop. Okay. Okay. Now after this, I will just increment I for the next operation. Right. And in the end, I will just return the operations needed. Let's see. Okay, KCDH accepting. Why do I think this will not work? Why? Okay, this will work. I'm talking about the minimum operation. So what I'm doing is I'm finding the next. That is the minimum. Yes, I think sure it should work. Let's submit. Yeah. Okay, the time complexity of this question will be, so this will be what? This will be n cross k, right? This will be n cross k, and this is nothing but this n square. So n cross k or n square, I think it is same. Okay. Let's see other solution. Next combination plus English 2 point what? Oh my god. Wait a second. Let's spilled the water. Okay, okay. Hello, hello. Mic check, mic check. Okay, okay. Hello, hello. Mic check, mic check. Okay, let's move on to the next question. Okay, let me see what they have done. Oh my God, they've used pointer, linked list. I don't think so. Next linked list is not in the adjacent swapping. Next combination. I think this is the two-part really very approach. Okay, okay, they have done the same thing. Okay, let's move on to the next question. Okay, let's reset the timer. Okay, let me check the stream once again. Super. Really very approach. Okay. Okay, they have done the same thing. Okay, let's move on to the next question. Okay, let's reset the timer. Okay, let me check the stream once again. Okay, let's start. So, question is maximum subarray main product. Okay, product of an array. Let us see. Okay, the main product of an array is equal to the minimum value in the array multiplied by the array sum. Okay. For example, this array 3 to 5 has a sum of how much? I think 10. And the minimum value is 2. So 2 into 10 will be 22. Given an array of integer nums, return the maximum main product of an non-empty subarray of nums. Since the non-empty subarray of nums. Okay. Since the answer may be large, return it modulo. Okay. Note that main product should be maximized before performing the modulo operation. Test cases are generated such that the maximum main product without modulo will fit in a 64 signed integer. Okay, okay, okay. Hmm. So if I think about brute force, then what I can do is I can use a prefix sum, and I will then what I will do is I will iterate on the every subarray and I will calculate the minimum while calculating the subarray, and I can just do it. The time complexity of that solution will be brute force solution will be n square, and I don't think so they will be happy about it. It is 10 to the 5. Okay. So let's say I need to maximize the main product, right? So what is main product? Main product is the minimum value multiplied by the sum. Okay. So for a current subarray, the main product is minimum of the subarray multiplied the sum of the array. And I want to maximize it, right? Now how can I maximize? Either I can maximize the minimum or I can maximize the sum, right? There are only two options. Okay, let's say okay, this is a question on survey. Okay, 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 okay. 3, 3, 6, 7, 8, 16, 39, 36, 68, 18. Okay. Okay. Nums of length. Okay. Hmm. Mm, yeah, I want to maximize the main product. Okay. What should I do? Either can I use something sliding window? No sliding window how? Because we don't know the size of the array, right? Sorry. Size of the subarray can be anything. Right. Okay. If I want to maximize it, either I have two options. Either I can maximize the minimum or either I can maximize the sum. Right. Okay. So, yeah, let's see. The maximum in product is achieved with the summary 3. Okay. I want to maximize it. Suppose my array is like this. 1, 2, 3, 2, right? Currently, I am at standing at 1, let's say. Okay, either my answer will start from this or not. 1, 2, 3, right? Okay, let's say, okay, I think so I got the intuition. So what I will do is, in my opinion, what I think is, let's say what I will do is, I will iterate on every element and I will say, okay, this will be my minimum element. Like this will be my minimum element. Okay. Now, if this is my minimum element, I will look on the right hand side till the moment uh, till the moment they are all greater than this, and also on the left hand side till the moment they are also greater than this, and I will just calculate it. Like suppose let's say 1, 2, 3, 2. Okay, I'm standing at 1, right? I'm saying okay, this will be a minimum element. Okay, I'm not saying that my subvariable will start from here. I'm saying just that my what my minimum sorry my what my minimum element is this. So I will go on till right hand side till the moment I got an element less than 1. Okay, right hand side is there is none, and on the left hand side there is none. Okay, so what I will do is I will calculate the sum. Okay, similarly 1, 2, 3, 2. I will go on to and I will see till the moment I get the less than. This solution will work, but still what I'm looking for is next smaller, right? Hmm. Maybe I need to calculate the prefix minimum. Let's say 1, 2, 3, 2. So what I need to do is, let's say I'm standing here. I need to check on the left hand side. Left hand side will be like this: 3, 2, 1, -1, 4. Uh, let's say on the right hand side the prefix minimum looks like this: 7. Then let's say becomes 5. Then let's say become 3. Then let's say become 2. Okay. Okay. I need to do this from here till here, right? Here till here. Hmm, let's say I have an element 3. So I will go on to the left till the moment all the elements are greater than or equal to 3, right? Greater than or equal to 3. Uh, am I right? Yes. Okay, okay. So let's say 1, 2, 3, 2. From here onward minimum क्या है? Okay. Here onward minimum क्या है? 1. Here onward minimum क्या है? 3 or 1, 1. Okay. No, 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 no. Getting the wrong answer. Uh, solution will work, but I need to somehow think that how can I calculate the left part easily? Because if I'm iterating on the, I'm thinking of something like binary search. Okay. because I can calculate the sum in O of n using prefix sum. I just need to find the value where if I include that value in my subarray, then it will not be the issue. It will give me issue, right? Okay. Let's say I'm standing at 2. I will go on till left till the time I get all the values greater than or equal to, right? Greater than. So on the left, it should be either equal to the value or greater than the value. Hmm? Hmm. 1, 2, 3, 2. Okay. For 3, this is the position, right? For 2, this is the position. Let's say, let's do the this example 3, 1, 5, 6, 4, 2, right? Let's say this, let's say, okay, let's this 4, right? On the third example, let's say I'm talking about the 4. I'm saying, okay, this will be my minimum element in the sub-array, right? So what I will do is I will go on to the left so that they are all greater than the 4. Right, is 4, okay, 4 is greater. So what is the minimum value? Minimum value here is 6, here is 5, here is 1 minimum value. Okay, here is 1 minimum value. Mm. Well, let's say this minimum value is 2, minimum value is 2, 4. Still, there is nothing clear. Okay, wait a second. Wait a second. Wait a second. Let's say, okay, let's say I'm calculating for 4. I will go on till right. I will go on till left. Right? Right. Uh, no, 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 no. That will be not be the issue. Oh, okay, this is more interesting question. Hmm. If I get the intention of doing this, then it will be a simple. What I need to do is I need to find the index of the position, which is the minimum than this. Index of the position, which is okay. So what I will do is I will push this in the array 3156 and also the index. 3156. Hmm. 56. Okay, they are sorted according to the value. So, okay, can I do? What can I do? 2, 3, 3, 3. Okay, it will be like 1, 3, 5, 6. What I am doing is 4. I don't know, 4 is small. Let's say 4, 5 is here, then what? Hmm. But let's say I'm talking about 4. Okay, okay, should I calculate for this? Let's say for this, 5, right? This, for this, yes, okay. Hmm. 2, 3, 2. How can I calculate this? Let's say, am I thinking correctly that considering all elements as minimum? Because I cannot get the first position which is less than that. I mean, I can get, but it will be an n-square solution, which is still not correct, right? Is there a way where I can get the minimum value? 3, 1, 1 is 1, 5, okay, 6, okay. Hmm. Mm, 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 mm. No, one comes right. So one is made up. One is not. Five is made up. Five. Six is made up. Six. Okay. I got the four. Okay, let's say it is three, right? Okay, let's say comes. Let's say it is six. Let's say comes four, four, 7, 8. Let's say I want to pick. This should also be included. Okay. Okay. Let me think something different. I am not getting stuck to this. I want to maximize this. So either I can maximize the minimum or I can maximize the sum, right? Okay. Some can be maximized, yes, some can be maximized. I think this should work, but I don't know how to calculate the next position where these elements are. What I need to do, let's say, let me thinking again. So I'm standing at 4. What I need to do is I need to find the index on the left hand side of the 4, which is the minimum, which is first and minimum to it, right? Which is less than that, not equal to, but less than that, and that is 1. And how can I calculate this? Can I use, okay, here onward 2, minimum is 2, minimum is 2, minimum is 2, minimum is 1. Okay, so for this, whatever this part is there, I should not include this, right? That's the maximum. 3, 3, 5, 6, 4. Sorry, 6. What is this? 4, okay, 6, 5, okay, 3. Oh, let's say 7. 7 should be, okay, okay. Um, then why? How to do this? I want to maximize the main product. Can I use binary search here? I don't think so. Because let's say I calculate, okay, I need to find the maximum. Okay, I don't need to find the range. Okay. I know this will work, but I don't know how to calculate the mu on the right hand side in the first index. Let's say I push this like this 3, 1, 5, 6. Now I'm coming 4. So what I need to find is okay, okay, let's say 0, 3, 1, 5, 6 is there, right? Okay, I don't need 0. Okay, I don't need 3. I just need, okay, these are the element which has the, and among these I have to choose the maximum index number, right? Yes. Okay. Okay, let me, what I will do is I will firstly sort the values. Can I get the maximum from this? Okay, I think I can do this now. Uh, 0, 3, 1, 5, 6. Okay, I need the 4. Okay, I know these are the, and among these I have to choose the maximum index. And how will I do that? How will I do that? Mm, hmm. Yeah, this is a good question. New values to how can I calculate the left part and the right part? Can I calculate it separately? What do you mean separately? If for every element I can calculate what is the minimum value on its left hand side, then it will be a piece of cake. 315642. So now my question becomes given an array, right? Given an array 315642, find the first element on the left hand side which has a value less than that. Okay, now my question becomes this. How can we do this? 3164. So I have counted all 3156. Okay. So I know the values which are less than this are 3, like 3. Now among this 1, 3, I know that one has a higher index. So I have written that. Still, I don't know. La 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 la. तो कैसे करें इस क्वेश्चन को, कैसे करें? 31564 315 how can I calculate it? That's a 315, right? So that's why I sorted them out with 316. I found out the elements which are less than that. Okay, I found out. Among these also I need to find the maximum index. That will not be the illustrated. Okay, I don't think so. I will do this right. Okay. Yeah, let me do it later. Okay, let's end the stream now. It is fine.